So I want to start by just giving a little bit of warning, and sometimes when we talk about technology and job growth, it's not for the faint of heart. I'm going to give you two quick examples. One is, I parked my car today, and there was a place for a parking lot attendant, and I looked in the little house there, and there was no parking lot attendant. Instead, I went over to a kiosk and put my credit card in, and then I was able to do that, put my little sticker on the car. And so when we think about technology and job growth, we wonder what happened to the person who used to be that parking lot attendant. Well, hopefully that person became enrolled here at this school and went off to do great work someplace else. The second example I'll give you is our railroad industry. If you go back to the early 70s, we had about 500,000 people in the national railroad industry. Today we have less than 200,000. But we're actually handling about 70% more gross ton miles or more units. And the reason we've been able to do that is all through technology. And as we've been able to implement this technology, it's quite frankly made us a much more efficient, much more competitive carrier. And then quite frankly, to be able to handle our customers' business, to be able to ship their freight further and further around the United States as well as around the world. I applaud Senator for having this technology summit, and I look forward to hopefully painting a new picture of the railroad that you will be able to see. All right, so we've got a clicker here, and hopefully, there we go, perfect. So I'm going to start with a little background on the BNSF and the industry in general. U.S. freight railroads operate across about 144,000 miles, and we certainly are the workhorse of the economy. We deliver about 40% of all the intercity freight volume, more than any other mode of transportation, and we do it more efficiently than most transportation modes. Only the barge industry would compete with us, which means, again, shippers pay less for shipping via rail. We also help to reduce congestion, lessen wear and tear on our nation's highways. You may have seen the commercials. One double-stack intermodal trains removes more than 250 trucks from the highway. And BNSF can move a single ton of freight 500 miles on a single gallon, reducing greenhouse gas emissions by about 75%. Well, certainly turning to BNSF, we consider ourselves to be a leader in the industry. We have 32,000 miles of rail lines. We run about 1,500 trains a day. We operate in 28 western states and 3 Canadian provinces. We serve more than 40 ports and 25 intermodal facilities. Last year, we shipped the most units in the railroad industry, more than 10 million units. That's an intermodal shipping container, a carload of coal or grain or tank car. We have about 47,000 employees with more than 2,500 here in the state of Montana. We move about 2 million loads of freight in the state annually. Montana is certainly an integral part of the BNSF operations. It's part of the BNSF Seattle to Chicago Great Northern Corridor. This corridor links the agricultural and energy resources here to the Pacific Coast and the Midwest and beyond. BNSF moves the goods that Montana produces and those that it consumes. A network of this size and scope requires significant capital to maintain, much less expanded, and that's what we've done. In Montana alone, we've invested over $450 million in the last 3 years to increase capacity. The total investment in the northern tier new capacity over this same period has been about $3.5 billion, which is truly an unprecedented expansion of freight capacity that includes over 140 miles of new double-track railroad. We've been transforming this northern corridor to the same functional level as almost completely double-tracked the southern transcon corridor between Los Angeles and Chicago. Since 2000, BNSF's invested more than $50 billion in infrastructure and equipment. The last 3 years have represented the largest capital programs ever, records for us and for the industry. In addition to network expansion, BNSF's $6 billion 2015 capital plan includes things $2.9 billion on renewal of assets and maintenance, things like replacing, upgrading rails, ties, and ballasts, which are critical to the efficiency and safety, as well as $200 million for positive train control, which I'll speak to in a moment. North American railroads are having their safest year on record to date, year over year. Since 2000, the train accident rate's fallen more than 45%, and rail employee injury rate fell almost 50%. The reduction in accidents over this period occurs as volumes increased, including volumes of hazardous materials. Technology contributes to this best ever freight railroad safety results, but it's only a part of how we got here. It's also safe operating practices, a culture of commitment to safety by our people and investment. But let's talk a little bit more about technology. Railroads are currently implementing positive train control. In 2008, Congress mandated its deployment by the end of 2015, this year, on all routes carrying passengers or toxic substances such as chlorine or anhydrous ammonia. PTC is the most significant technological change in the modern era of railroading, including the transition from steam to diesel locomotives. When PTC is up and running, it will work as a technology overlay of existing train operations. Using GPS, Wi-Fi, and high-band radio transmission, PTC will be able to determine the location, direction, and speed of the train, warn the locomotive engineer of a potential problem, and take action, i.e. stop the train if there's not a response by the engineer. This technology will be important to avoiding the extreme rare but catastrophic human-error accidents like head-on collisions, and in the future could help railroads to run more efficiently and realize more capacity. But as we approach the December 31st, 2015 congressional deadline, the industry is far from that. At the moment, it's still an unprecedented technological and operational challenge. BNSF is the furthest along. We've developed the technologies even as we were implementing the systems, and the system will have to be extensively tested before it can be declared done. We're testing it now, where we've deployed it, and the potential impacts to network capacity and fluidity are significant as we work the bugs out. Congress will need to move the deadline to ensure that we can do this. Currently, we're committed to the PTC deployment, but we're equally committed to doing it right. PTC brings together newly developed technology for locomotives, wayside communication equipment, and back office systems, and involves the deployment of approximately 500,000 pieces of technology across the national rail network. And since the technology needs to function within the railroad's existing communication and dispatching system, for every train on the railroad's PTC network, each railroad is developing a separate PTC system, which must be interoperable with every other railroad's, which, as you can probably imagine, is even more complicated. At BNSF, we have more than 10 separate teams involved in the installation. Our architectural team is designing the overall PTC infrastructure, including how all the software and hardware will communicate to each other. The Geographic Information System, GIS team, is creating locomotive onboard and back office databases that contain safety-critical information that allows the locomotive to navigate track geometry, communicate with field devices, and feed the braking algorithm. Our signal folks are installing and inspecting and will ultimately monitor all the signaling hardware for PTC. The installation is more than just a team sport. It's a well-orchestrated symphony. It's a pretty amazing project, since virtually none of this technology existed 5 years ago. We're currently thinking how to leverage the infrastructure created from our $2 billion investment in PTC to increase railroad capacity and operational efficiency. Another area of technological advancement is in asset health. We use technology to monitor track and equipment real-time and engage in condition-based maintenance. But we're going beyond failure detection. Leveraging big data analytics, we'll be able to predict how unsafe conditions develop and then prevent them. Let me explain. BNSF has more than 2,000 trackside warning detectors that collect data 24/7 year-round across the system. These detectors continually monitor the overall health of passing trains, use a combination of thermal, acoustic, and vision systems along with other technologies. We use machine vision systems, camera-based technology that generates high-speed, high-resolution images that can show defects such as worn truck components, worn brake shoes, and missing bolts in a coupler carrier plate. These systems can identify equipment defects in motion at more than 70 miles per hour, day or night, rain or shine. There's actually 12 types of technology used across our network of more than 2,000 equipment detectors. Here's one example of an acoustic bearing detectors listen for sounds that are generated by specific bearing component defects, and hotbox detectors measure bearing temperatures to watch for brake issues. All in all, our network of off-track, on-track, off-track equipment detectors generate more than 100,000 readings a day. Now that is certainly a lot of data. For track inspections, we run our high-tech inspection fleet continuously, testing hundreds of thousands of miles of track using ultrasonic waves to inspect rail for internal defects and a combination of lasers, visioning systems, and ultrasonic and ground-penetrating radar to inspect track geometry and roadbed. BNSF's also received a lot of attention recently for its effort to incorporate the use of unmanned aircraft systems, or drones, into our safety program. BNSF has begun to use supplemental track, bridge, tunnel, and other infrastructure inspections to add to additional layers of detection. These flights are low altitude and stay within our right-of-way. Initially, we were approved for line-of-sight flights, but earlier this year, we were one of the 3 companies awarded Pathfinder program status by the FAA for extended track integrity flights, meaning longer distance and beyond the direct vision of the pilot. So how do we leverage all of this asset health information coming from our equipment and rail and track detection programs? We're using big data analytics to take this information that we already use to detect deviations from safety standards to understanding the factors that create them, predict how accidents could and do occur, and prevent them. Analytics will allow us to go from absolute alarms, which tells us something requires to be repaired, to composite alarms, which tells us contributing conditions have been combined in such a way that an unsafe condition could or is likely to occur. It can show us connections between equipment health and other elements of safety program, like track integrity and train handling. Big data analytics will allow us to monitor equipment health over time, geography, and across railroads, and assist in developing technologies for safety, extending equipment asset life, which not only improves safety, it creates capacity. The ultimate goal, though, is to improve decision-making to reduce risk. One of the most elegant descriptions of how this works is actually an IBM ad that they ran during the Masters, and I'd like to show it to you now.
Of all the causes of train derailments, one is especially hard to spot: a single cracked wheel. And out of more than 1.5 million wheels, how do you find the right one? You can't hear it, but analytics can. Working with IBM, a railroad analyzes 100,000 data points a day to help stop trouble before it starts. IBM Analytics is working to make every industry smarter every day.
The reality and the potential of technology on the railroad is very, very incredible. The railroad will always be steel wheels on steel rail. The technology is fundamentally changing the operations and the maintenance of the network, and it's changing our workforce. Our IT department is in the midst of a technology roadmap that has tripled the investment in our systems department. The 1,300 men and women that make up our IT department are working on a host of projects that will impact almost every aspect of our day-to-day operations, but that's just one example. Our company and our people embrace this innovation. Well, I hope you get to see a lot of BNSF trains while you're visiting here in Montana. For those who live here, I know you do already. As you see one go by, consider the technology advancements that make it one of the safest, most efficient ways to move freight and the economy today. Thanks again, Senator Daines, for inviting me to participate in your summit.